All right, so the unit circle is simply a circle with a radius of 1, and it is defined by the equation x squared plus y squared is equal to 1. We're not really going to do a whole lot with this equation at this point in time. However, next year in pre-cal, you'll learn some trigonometry identities that are going to be dealing with using this equation. So this is just a picture of your unit circle. The unit circle will always be centered at the origin, 0, 0. And with a radius of 1, your unit circle will go through the coordinates 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, so what we're going to take a look at now is finding out the angles in radians for what are called the familiar angles going around a unit circle. And these familiar angles are going to be the same angles that you worked with in geometry when you were working with 30-60 triangles and with 45-45 triangles. Those were called your special right triangles. Now, the first angle that we're going to be coming to is this angle right here, this point. And so what we're going to look at doing then is making a triangle to try to figure out the coordinates of this point. And the triangle we're going to make is going to go straight down from that point at a right angle to the x-axis. And then you have this radius and then our bottom side. So that's going to create our triangle here. Now the first angle that we are going to be using is going to be a 30-degree angle. What that does is it creates a 30-60 triangle. This is the unit circle, which means the length of our hypotenuse right here is going to have a length of 1. In fact, all of these spokes coming out of this wheel are going to have a length of 1. All right, so we have a length of 1 for this side of the 30-60 triangle. Now, on a 30-60 triangle, you may remember your properties from geometry, or not, but if this side has a length of x, the hypotenuse has a length that is twice that measurement, and the long leg is x times the square root of 3. So those are your properties from geometry. So in this particular problem, if our hypotenuse is right here with the length of 1, to find the short leg, we would need to take half of that, and half of 1 is 1/2 for the length of this leg. All right, so to find the length of this side of the triangle, we multiply whatever this is times the square root of 3. All right, so that means the bottom side of our triangle here is going to be 1/2 times the square root of 3, which is the same thing as square root of 3 over 2. Well, when you write a coordinate, the coordinate is going to be in terms of x, comma, y, and to get to this point right here, we are moving to the right, square root of 3, and up 1/2. So the coordinate of this point is going to be root 3 over 2, comma, 1/2. All right, so now let's work on this next triangle. Let me take this one off of here. All right, so our next triangle is going to go to this point up here. And when we draw this triangle, this is going to create a 45-45 triangle. And on this triangle, the hypotenuse is still 1. So let's review our 45-45 triangle rules from geometry for just a second. When you had a 45-45 triangle, the length of the two legs are the same length, and the hypotenuse is x times the square root of 2. So what that means is that if we know what the side is, you would multiply by square root of 2 to get the hypotenuse. Well, if you know the hypotenuse, to find the leg, you would do the opposite of that then, which means we're going to divide by square root of 2 to find out the length of this side. All right, so when you take 1 and divide it by square root of 2, that will give us the length of x, which is this bottom side of the triangle. And on the 45-45 triangle, the legs are the same length, so this also is 1 divided by square root of 2. Now, 1 over square root of 2 is not a simplified fraction. The way we simplify, or whatever the rule for this is that when you have a radical, which means a square root or a cube root or just a radical symbol, when you have a root in your denominator, it is by definition not simplified. And so what we're going to do then is work with simplifying this by using a process called rationalizing the denominator, because square root of 2 is an irrational number. So we need to turn it into a rational number. So what we're going to do is we are going to multiply this fraction by some number that will turn square root of 2 into a rational number. And the number we're going to multiply by is square root of 2, because the square root of 2 times the square root of 2 is the square root of 4, which is 2. Now, you have to be careful because we can't really change the value of this fraction. And the only thing that we can multiply by and not change the value of this fraction is 1. So that means if our denominator is getting multiplied by square root of 2, then our numerator has to get multiplied by the same value. And see, multiplying by root 2 over root 2 means you're really just multiplying by 1. So you're not changing the value of this fraction, you're just changing what it looks like. So in the numerator, we have 1 times the square root of 2, which is square root of 2. That is most often how you will see this side represented, is root 2 over 2 for the x value. The y value is the same, so it also is root 2 over 2. All right, now let me go ahead and take this information off, and we will look at the next one, which will be the last one on this unit circle. All right, so we're looking at this point now, and so we're going to draw our triangle coming straight down, perpendicular to the x-axis. Draw the hypotenuse here, and this side where this is x and this is y, and this has a length of 1. This is going to be a 60-degree angle here, which means this will be a 30-degree angle. All right, so what this tells us is this is a 30-60 triangle, just like this one up here. Hypotenuse is 1, so that means the short leg will be half of that. So if the hypotenuse is 1, x is going to equal 1/2. And y will be the square root of 3 times the 1/2, which is root 3 over 2. So that gives us our coordinate of 1/2, comma, root 3 over 2. All right, so what I want to take a look at now is going to be our angle measurements in this first quadrant. Now, the angles that we worked on with the triangle were in radians, and so we need to look at they were in degrees. And so what we need is the radian equivalent. So this first angle right here was 30 degrees, and the radian equivalent, well, let's think about the conversion. You change a degree to radian by multiplying by pi over 180, and so that's going to reduce to pi over 6, and so that is the angle for this first point that we come to. All right, so the next point right here, that was a 45-degree angle, and if you multiply 45 times pi over 180, that's going to reduce to pi over 4. And then the third angle, we used a 60-degree angle, so 60 times pi over 180 will reduce to pi over 3. All right, so then the angle up here at top, this is a 90-degree angle, which 90 times pi over 180 is pi over 2. This coordinate is 0, 1, because a unit circle. The angle that we started out at was 1, 0 for the coordinate, and that angle was 0. Now it is 0 if you are starting here. You also could be rotating around one full rotation, and one full rotation would be an angle of 2 pi radians. And let me take some of this off here. All right, so what we want to look at then is these points that we have found the coordinates for are going to be the same coordinates all the way around our circle. The only thing that we are going to be changing is going to be the signs of those coordinates based upon which quadrant we are in. So then the points that are in this second quadrant all have an x value that is negative and a y value that is positive. So right away we can just put a little negative sign on our x values because we know they're all negative. And this point is going to have the same coordinates as this point. The only difference is our x value is negative. And so the coordinates here are going to be negative 1/2 root 3 over 2. This point is going to have the same coordinates as this point over here, except the x value is negative. So we're going to have negative root 2 over 2, positive root 2 over 2. And then the last angle is going to be negative root 3 over 2, 1/2. It is the same coordinates as the one across from it, except the x value is negative. Now, as far as our angles are concerned, let me just go ahead and write these angles in here real quick. This one will be 2 pi over 3. This one is 3 pi over 4. And this one is 5 pi over 6. And you can do the conversions. This one is 120 degrees, 135 degrees, and 150 degrees. The next point is going to be negative 1, 0, and this angle is at pi. All right, so what I want you to do now is I want you to finish going around this circle, filling in the coordinates. I want you to pause the video, fill in our coordinates, as well as the angle measurements in radians going all the way around. So go ahead and pause the video and fill those in, then you can unpause it and fill in your notes. All right, welcome back. And so one of the things that you're going to have to do is you will have to memorize this unit circle. And there are some things or patterns that you can look at to help you with memorizing. So this one right here, if you notice all the angles that are over 4, you have this one right here, this one over here, this one over here, and this one over here. These angles are all over 4. Well, what do they all have in common? Both the x and y coordinates are √2 over 2 on every one of them. The only difference is there's a negative on some of the numbers depending upon which quadrant you are in. In the second quadrant, the x value is negative. In the third quadrant, the x and the y value are negative. And in the fourth quadrant, only the y value is negative. So all the angles that are over 4 are √2 over 2. Now look at all the angles that are over 6. You have this one over here, this one, and this one over here. Look at the coordinates. Every one of those starts with √3 over 2. Now you can try to remember 3 times 2 is 6. So all the ones that are over 6 start with √3 over 2. Now some of them change and put a negative on them depending upon which quadrant they are in. 1/2 is always paired with √3 over 2. For this coordinate, this coordinate, this coordinate, this coordinate, 1/2 is always paired with √3 over 2. When it's pi over 6, the √3 over 2 goes first. When it's pi over 3, which is here, 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 and here, when it's over 3, 1/2 is the first fraction. And again, depends upon which quadrant you are in. You will have to put a negative on some of those values. All right, so let's take a look at this. Go ahead and put that unit circle away for just a second, and let's practice finding some of these coordinates. So without looking at the unit circle, let's figure out what is the coordinate of the point on the unit circle with the given angle measurement. All right, so pi over 2, that was the angle that was straight up. That coordinate was 0, 1. And once again, that was the angle that was right here and then straight up here. All right, 3 pi over 4. 3 pi over 4 was the angle from here, halfway over here. And remember we said over 4 always is √2 over 2, √2 over 2. Now because this angle is in the second quadrant, or this point is in the second quadrant, your x value will be negative. All right, so the next one is negative 2 pi over 3. All right, so let me put something on here real quick. All right, so normally for 2 pi over 3, you would rotate around this direction, and that would be your angle for 2 pi over 3. Negative 2 pi over 3 tells us to rotate the other direction the same amount. So this would be your angle for negative 2 pi over 3. And the coordinate at this point was negative 1/2 negative √3 over 2. All right, and then the last one, 9 pi over 4. All right, so with 9 pi over 4, what you're looking at doing is, if you rotate all the way around one complete revolution, that's 2 pi. Well, 2 pi is the same thing as 8 pi over 4. So what we need to do is we need to rotate around 8 pi over 4, but then go an extra pi over 4. So this is the location that we are going to be looking at. And the point here is the same as just pi over 4. And that coordinate was root 2 over 2 and root 2 over 2. Both of them are positive because we are dealing with the first quadrant.